Okay, this is Mr. Abbott, and I'm going to try to quickly go through drawing the path of the sun for 6 different locations. Now, it's asking to draw each of the seasonal paths. The first one is for 0 degrees, which is at the equator. To find the path of the sun for the equinox, you're always going to do 90 minus your latitude. So for the equator, I'm going to start off with 90 minus 0 would give me a 90-degree angle on the equinox. So on the equinox at the equator, sunrise would be due east, sunset would be due west, the sun would go directly to the zenith, and the sun would go straight up and straight down. At the equator, it rises and sets perpendicular to the horizon. Now, I've got 23.5 degrees north and 23.5 degrees south. So for the equinox, I would do 90 minus 23.5, and what I'd get here is a 66.5 degree angle. When I draw an equinox path, it rises directly east and sets directly west. So for both of these paths, it would rise directly east and set directly west. The noon sun would shift down by the 23.5 degrees. Now, in the northern hemisphere, you look south to see the noon sun. So I'm going to put a point here for the noon sun, but from the northern hemisphere, the path slants to the north. If I'm in the northern hemisphere, the path slants to the south. From the southern hemisphere, or the Tropic of Capricorn, I'd get the exact same angle because I'm the same distance away from the vertical ray. The sun still rises in the east, but now it's going to set to the west. 50 degrees north and 50 degrees south. I do 90 minus 50, and I would get a 40-degree angle. So, an equinox is due east to due west. Okay, it's 50 degrees down from the horizon, so it's a little bit more than halfway, and the angle is going to look like that. Okay, from the northern hemisphere, the noon sun is to your south. Now, from the southern hemisphere, it rises due east and sets due west. I'm still getting that 40-degree angle, but this time it's a 40-degree angle over the northern horizon. So the path is going to go up and down, and that's only going to be 40 degrees above the horizon. Now, this would be weird. If I do 90 minus 90, I'm getting 0 degrees. Okay? That means if I'm on the North Pole, the sun rises directly east, the sunset is directly west. Okay? And the path would be going around the horizon if I can draw it. Here, it rises to the east and sets to the west, and it would be moving this way. Now, honestly, if this was exactly at the South Pole, every single one of these directions would be north. And if you were at the North Pole, every single one of these directions would be south. Now, to make this a little more obvious, for the equinoxes, I'm going to highlight them in yellow. The farther away you're moving from the vertical ray, the lower the altitude or the angle of the sun. for these, you're 90 degrees away from the equator, you're 90 degrees away from the vertical ray, so now the sun appears to move across the horizon. Now, for summer, you have to add 23.5 degrees. So this was a... Whoa. I'm fine. That's not good. Camera just fell. Not what I was expecting. So, here we go. And it's still taping. Amazing. There we go. Better. Now, for the summer solstice, you add 23.5 degrees. So this one is going to shift up by 23.5 degrees. So on 6/21, you would do 66.5 plus 23.5, and you'd get 90 degrees on June 21st. So that means the sun would hit the zenith on 6/21. So the 6/21 path would be directly overhead. Now, 6/21 would be the winter solstice. So this is an equinox. That's 66.5 degrees. I do 66.5 degrees and I'd subtract 23.5, and then what I'm getting is a 43-degree angle. So for summer solstice, for June 21st, sunrise is north of east and sunset is north of west, but now it's the longest, highest path in the northern hemisphere. It's the shortest, lowest path. For 6/21 in the northern hemisphere, I add 23.5 degrees, and I'm getting 63.5 degrees as our maximum angle. So it's June 21st, it rises north of east, sets north of west, and now I get the highest angle for the year, which is 23.5 degrees up, which is 63.5. For 6/21 over here, it's winter, so I go down by 23.5 degrees, and I get 16.5 degrees. 40 minus 23.5 is 16.5, so it's north of east to north of west, but now the sun's path is going to be much lower. Now, I'm taking the equinox. For 6/21, I've got 0 degrees for the equinox. I add 23.5 degrees, and what I get is 23.5 degrees above the horizon. Now, the North Pole would have no sunrise and no sunset on that day. So you'd get 24 hours of daylight, but it would still be cold because the sun is at a low angle. Over here, you do 0 minus 23.5, which means I'm getting a negative value. The sun is below the horizon by 23.5 degrees. So on 6/21 at the South Pole, you'd have complete and utter darkness. Now, for the summer at the equator, it's still June 21st. It's going to be north of east to north of west. It's got to shift by 23.5 degrees. So now, to move off of the zenith, I'd have to go 90 minus 23.5 degrees. It would be north of east to north of west. And we have some technical problems again, but north of east to north of west gives me a 66.5 degree angle. So it's going to go straight up and straight down. Okay, I'm going to use the green highlighter, and I'll do the summer paths in green. But you've got all of the angles there. Okay, in the southern hemisphere, June 21st is the winter solstice, so it's the shortest, lowest path. Alright, now I gotta figure out, my tripods just are not working here. There we go. So this is going to be a shorter, lower path. The North Pole is 24 hours of daylight, and the South Pole would be having 24 hours of darkness on June 21st. Now, quickly, before this falls again. Okay, December is south of east to south of west. At the equator, it would hit a maximum of 66.5 degrees, but on the other side. Here, the sun would go down by 23.5. So we already did the calculation here. 66.5 minus 23.5 means this would be a 43-degree angle. So in winter, it's south of east to south of west, and we're getting a shorter, lower path. In the southern hemisphere, it's got to go up by 23.5. So now, when 23.5 degrees north is getting a 43-degree angle, okay, the Tropic of Capricorn, the sun would hit the zenith, and it would be getting a 90-degree angle. Winter shifts down by 23.5. So 40 minus 23.5, we already did that over here, gives me a 16.5 degree angle. This one, I'm starting at 40 for the equinox. I have to move up by 23.5. So 40 plus 23.5 gives me the longest day in the southern hemisphere. It's south of east to south of west, but now the noon sun shifts to the northern horizon. At the North Pole, if it's 1221, 0 minus 23.5 degrees gives you a negative number. That means it's below the horizon, there's no sun. Here, 0 plus the 23.5 gives you 23.5 degrees, but now the South Pole is in complete, absolute daylight, but the angle is still only 23.5 degrees, which means you're getting 24 hours of daylight, but it's not very warm. So I can do the last one in blue. The lowest angle you get at the equator is 66.5 degrees. Okay, so that would be 66.5, 90, and 66.5. Okay, but no matter where you are between summer and winter, the angle of the sun has to change 47 degrees. Okay. It's going to change 23.5 degrees each season. Okay, but you can really tell if it's northern hemisphere. A northern hemisphere path slants so the noon sun is to the south, and a southern hemisphere path slants so the noon sun is to the north. I hope that clarified things. Sorry about the problems or issues with, the camera sliding off the tripod. It takes a while to get through this, especially when things start falling. So I hope that helps your understanding of drawing the path for different latitudes.